Hey everybody, it's me, Mr. M, and I'm up here at Snow Summit in beautiful Big Bear Lake, California. I've just been riding the slopes a little bit, carving some snow, and it made me think. I was thinking, as I'm riding down these slopes that I'm riding down are they're kind of like the downhill slanted part of a right triangle. You know that one side of a right triangle that's like not perpendicular to the other side? Well, that slanted part has a name. The name of that slanted side is called a hypotenuse. That's a really weird old Greek word. Hypotenuse, hypotenuse. I happen to be snowboarding down a hypotenuse right now. Here, take a look. I like hypotenuses. Hypotenuses are cool. They provide all kinds of fun for skiers and snowboarders, especially when they're covered with snow. I highly recommend that you enjoy yourself a hypotenuse sometime too. You know what? Speaking of hypotenuses and right triangles, I think I want to share a little bit more info with you.
Pythagorean Theorem. Yes, indeed. We've talked about Pythagoras. Now we're going to talk about the Pythagorean Theorem, which is named after him. Yesterday we said that Pythagoras noticed a strange relationship between the three sides of a right triangle. Remember, there's two legs and a hypotenuse? Well, what Pythagoras and all his Pythagorean buddies noticed is that all right triangles have side lengths that obey this formula. The square of one leg plus the square of another leg equals the square of the length of the hypotenuse. So we saw that with the 3, 4, 5 right triangle, but it works with any right triangle. So if you had one leg is 9 feet, another leg is 12 feet, then the hypotenuse would have to be 15 feet. That's the only way that this triangle would work, and I'll show you why. One leg squared would be 81. Another leg squared would be 12 squared, and that's 144. When you add those two together, 81 plus 144, you get 225. And that number has to be the hypotenuse squared. So that number happens to be 15 squared, so the hypotenuse must be 15. And it works for every single right triangle in the universe. It's true. There has never been a right triangle that does not obey that formula. And so it's a pretty famous formula in math, and it's called the Pythagorean Theorem. And it is that the square of one leg plus the square of another leg equals the square of the hypotenuse. Or we like to abbreviate that because instead of saying leg squared plus leg squared equals hypotenuse squared, it's a lot easier to just say a squared plus b squared equals c squared. And that's the equation that most people mean when they say the Pythagorean Theorem. The Pythagorean Theorem is really an equation, and the equation is a squared plus b squared equals c squared, where a and b are the two legs of a right triangle, and c is the hypotenuse of a right triangle. By the way, this only works for what kind of triangle? A right triangle. All right, so I'm just going to abbreviate that up here. We're going to use a squared plus b squared equals c squared.
Yeah, so you know what? It's interesting because if you want to find the length of the hypotenuse of a right triangle, all you have to do is know the lengths of the two legs. Because each of the two legs, we'll call them A and B, can be squared and then added together, and that will equal the square of the length of the hypotenuse. This is what we call the Pythagorean Theorem, aka a squared plus b squared equals the hypotenuse, or c squared. That's the Pythagorean Theorem, and that's a pretty cool thing.
We're going to use that to solve a problem. The problem is I don't know the third side of this triangle. I know that one leg is 8, and I know that another leg is 6, but what is the hypotenuse? We don't know the measurement of that hypotenuse, but we can use the Pythagorean Theorem to find it. So let's do that. One of the legs squared would be that 6 squared. The other leg squared would be 8 squared. The hypotenuse is x. We don't know what it is, so we have to just call it x. And when we put the plus and the equals in there, we get 6 squared plus 8 squared equals x squared. And now we're just going to use algebra to solve this equation. What's 6 squared? 36. What's 8 squared? 64. Oh, can you add 36 and 64 together? Sure. Oh, hey, that makes 100. Wait a second. 100 equals x squared. What number squared makes 100? Oh, yeah. X must be 10. Because 10 is the only number that, when you square it, gives you 100. And does it look like, in this case, x could be about 10 if the others are 6 and 8? That seems like that makes sense. Remember, the hypotenuse is always the longest of the three sides. But what if it wasn't a nice number like 100? What if this had given us an equation where it was like x squared equals 103? And you can't really unsquare 103 very nicely. What would you do in a problem like that? Well, sometimes Pythagorean theorem problems come out nice, and sometimes they don't come out so nice. So here's one that's not going to come out quite so nice. Also on this problem, notice the missing piece isn't the hypotenuse. Which one is the hypotenuse? The hypotenuse is the 5, isn't it? So the x is one of the legs. The other leg is 2, and the hypotenuse is 5. So x squared plus 2 squared equals 5 squared is how we're going to fill in our a squared plus b squared equals c squared Pythagorean theorem equation. Now I can simplify this. I don't know what x squared is, but I know what 2 squared is, and I know what 5 squared is. 2 times 2 is 4, 5 times 5 is 25. How am I going to get x? Oh yeah, I've got to subtract 4 from both sides so I can get x squared by itself. Hopefully I didn't lose you by subtracting 4 from the 25. But then, what number squared makes 21? I don't know how to unsquare 21. Oh, wait a second. If I want to unsquare the x to figure out what x equals, I've got to unsquare the 21 as well. And the math word for unsquaring is square rooting. So at this point, you kind of have to use your calculator because I don't think any of us have the square root of 21 memorized. In fact, that's an irrational number. It's one of those yucky decimals that's going to keep on going on and on forever. But when you round it, it comes out to approximately 4.58, or we could say that x is about 4.6 in this case. All right, that was an example of a more tricky Pythagorean theorem problem. So I gave you an easy one, and I gave you a more challenging one. And now it's your turn. Here's an easier one and a simpler one, and the answer to this one should come out to a nice rational number. Here's a weirder one, and you're not solving for the hypotenuse this time, you're solving for one of the legs. And your answer's not going to come out nice and rational. It's going to be one of those yucky decimals, and you're going to have to square root something on your calculator and have it be a messy, long number that you're going to have to round at the end. All right, if you can handle those two problems, you are a Pythagorean theorem machine, and that is all we have to say today. Good day.